So in this lesson, the big concept that I'm going to get across to you guys is continuous functions. So here we go. I'm going to start off by explaining what they are. First and foremost, I'm going to give you the English definition, the plain English, so we know what it means. And then I'm going to talk about the math definition. So first and foremost, in English, what we're looking for is the limit of a function at a particular value is the same as the function's value. Now, when we were first starting to go over this, you guys had some trouble distinguishing between a limit and a value, because when you went through pre-algebra and algebra 1 and geometry and algebra 2 and all of those other math classes, the functions that you dealt with most often were continuous functions. And so the limit and the value were indistinguishable. They were exactly the same thing. But here's the thing. They're not always, which is why we had to learn that in calculus. So again, if the function is continuous, in order for it to be, the limit and the function's value have to be the same thing. So I'm going to write that in math now. So here I go. The limit, that marker's not working. The limit as x approaches n of f of x has to be the same as f of n. As the same answer, the same number as when I plug in n into the function. So I'm going to also make sure I mention real quickly that this exact definition has three parts to it that I need to make sure are up in my head, that I'm thinking about it this way. The first part is that number one, the limit as x approaches n has to exist. I can't have any d/n/e limits. That's impossible to be continuous. It has to exist. Number two, the function f of x has to be defined at n. So no dividing by zero, no square roots of negatives, nothing like that where we get an undefined answer. Now, let me repeat again. d/n/e for limits, undefined for functions. All right? The third part is that they do in fact have to be equal. They have to make the same number. So there's actually three parts. Number one, I have to exist, I have to be defined, and they have to be equal. So that's all really important stuff that's going on in this one very simple statement. Now, that means, remember, it does not technically exist if it goes to infinity. So if you have an infinite limit, that's still not going to exist. It's still not going to be continuous there. And I'm going to come back and talk more about that in the next lesson when we talk about discontinuity. So the other thing that I want to go ahead and make sure I mention is that I don't want you guys to get confused between continuous and substitution. All right, so I'm going to write that very quickly in if-then form. All right, so again, the red does not work. So if the limit as x approaches n of f of x equals f of n, then f of x is continuous. This is my definition of continuous. However, this is different than the substitution property. The substitution property said the exact opposite. It said it backwards. So that's an important distinguishing factor, is continuity starts off by saying the limit and the value are the same. However, the substitution property has to be continuous first, has to be one of my special functions. And then I can just plug it in and find the limit. So make sure you understand the difference here between continuous and substitution. They are not the same thing. In fact, if you want to remember one of your good old-fashioned geometry words, they are the converse of each other. There you go, geometry term for you today. All right, now I'm going to come back in a little bit and do some more examples and talk more about this. So we're going to take it nice and slow. If you got any questions, make sure you ask me, please.